Hey, that was easy enough. Oh, I should present. I feel like that's a good one. Or is it already sharing?
Do you know
That's
the green exactly?
All right, so I guess we just begin whenever. All right, this will be a fun one. This will be a fun one. So,
Green point started.
we haven't even started yet. Hold up.
Give
Give it a bit. Give it a bit.
Yeah.
All right, we'll get there. So, good afternoon, everyone. My name is Michael Rivera, and this is going to be a presentation on syntactic movement. The big topics we're going to be covering are syntactic case and how that affects syntactic movement, and then syntactic movement itself. There's going to be a bigger emphasis on that latter topic. All of the information that you'll see here, all the references and all the quotes and whatnot, they are based on Carney's Syntax Generative Introduction from, it says 2014, but it's supposed to say 2021. 4th edition, which is why there's a 4 there. But I don't, is the book in the drive, or is it not in the drive? No, I don't
The
think it's
third
PDF
edition.
Yeah, the 3rd edition.
I don't think I have a PDF for the 4th
Yeah,
edition.
in the 3rd edition, all of the information is fairly similar. I think the only real changes are like in examples and whatnot, but all of the information is still there.
Exercises.
Yeah, and some of the exercises, but beyond that, it's very similar. So you could just check chapters 10 through 13. It's in section 4 of movement, I believe. But yeah, so we're going to be reviewing some of the stuff that we talked about in the previous syntactic presentation on theta theory. We're going to be first going just really quickly over X-bar rules, and I'm going to go quickly over theta theory because some of that terminology is going to be really useful for understanding these concepts about movement of case. Then we're going to present some more problems that we have not presented before, but now come up even with theta theory and X-bar rules, and we'll bring the powerful solution movement. And then we'll go through some cases of movement. We'll first discuss what WH movement is, and we'll then discuss what DP movement is, determiner phrase movement. And when we talk about DP movement, that is where case lives, and there's where we'll introduce case. And then we'll just go through some other types of movements that exist in English so you can kind of see how they all interact. And we'll answer the big question of, does there exist a generalized solution, which there does, and we just call it very creatively move. So to begin, we will discuss the review of X-bar theory. And if we go back to our memories, we will remember these 3 big terms, right? Complement, adjunct, and specifier, right? A complement is a phrase that is obligatory for a certain word's meaning to make sense within a sentence. Think of the word attached, right? Someone or something needs to be attached to something else. You can't just have attached. You can't just have attached to something, and you can't have something is attached. There needs to be more to completely fulfill that sense, you could say. Next, we have the adjunct. You can think of this as optional information that can be applied to a particular phrase. So if we think of a cat, we can also have a cat inside a boot. Right? Inside a boot is not necessary to complete the sense of cat, but we are able to do that. And so that optional piece, we call that an adjunct.
Yeah, we got optional information, but technically it's optional structure.
Optional
Yeah,
structure,
oh, yeah,
but,
optional phrase. But yeah, we got what you mean.
and then we have the specifier, which I'll just read it off here. It's a phrase that is not obligatory to complete the meaning of a given word, but it also specifies that word. Usually when we introduce syntax, we usually use determiners as a big example of this, where say we have a cat versus the cat. That determiner is really specifying which cat versus taking away the specification. So that's how we will see specifiers in play. And we'll see a bigger way in how specifiers play a role. They play a really important role in the syntax.
En el caso de algo como de gray cat, la palabra gray viene siendo adjunct o specifier.
Gray would be adjunct. Yes. So X-bar theory then.
Because gray can be a phrase by itself. What color is the cat? Gray.
Okay.
So you can use that as a whole phrase. It's a phrase.
And dog would be a specifier.
Yeah.
The dog would be, yeah, depending on.
We'll get there. We'll get there.
Yeah, we'll get there.
So to summarize how these will interact within the syntactic trees, though, we have these three rules. So we let X, Y, Z, and W just be any given syntactic categories. X-bar theory then lets us combine these components in the following three ways. We have one for each of the rules that we mentioned before. We have the complement rule, the specify rule, and the adjunct rule. You guys will have access to this presentation later on, so you can look at this in more detail. But you don't have to worry about the, like, it says the rule, and then it has like an arrow notation. Really, you can see the tree notation, and that kind of gives all of the idea of what the rule says. Complement rule states that it will have an X bar, and it will branch it down to a head X and a phrase YP, some other phrase that doesn't necessarily have to be the same as X. And similarly defined, we have the specify rule and the adjunct rule. And I think it's best that we show an example to kind of see how this all works out.
I imagine you're using the semicolon as you know, to represent the fact that the linear order is not relevant.
Yes,
For the rule.
exactly.
So you can have X at the, you know, the left, and the head, and then the complement at the right. But that would be for some languages like Spanish or English. But for other languages, it would be you will have the complement at the left and the head on the right. Okay. So the rule actually is not supposed to encode linear order. So that's yeah, at least in this mode.
Exactly. And so we'll see how this works in this following example. So here we have the sentence, John needs the papers for tomorrow, right? So firstly, to see the complement rule, we notice the verb needs, right? So when we say needs by itself, we're like kind of missing information. It needs something, right? And so there is an obligatory structure that needs to be present. In this case, we have the determiner phrase, the papers. And so what happens is really what we need there is a determiner phrase. In this case, we have it as the papers, right? And so that's how the complement rule is denoted. Note how the top node is V bar, and it branches down to the head V and the new phrase DP. That doesn't necessarily have to also be a verb. And like Hilton mentioned before, it's not strictly dependent on, like the linear order is not, it's not like strict. It could be in whatever order. In this case, though, it would need to be the head on the left and the phrase on the right.
And just a reminder, as a reminder, the determiner phrase is our fancier syntactic way of referring to noun phrase. Okay? Because there's a functional structure on top of it. Exactly.
So when it comes to the adjunct rule, we see this as an example. We have the phrase headed by the VP that heads needs the papers, right? Note how if you were to like go down the path from that VP downwards, you would cover all of needs and the papers, right? And it is the sister of the prepositional phrase node that encompasses for tomorrow. Now we could have just as easily said John needed the papers and leave it there. Note how for tomorrow is not obligatory for the sentence, or it's not an obligatory structure for the sentence to be complete. That's why we denote it as an adjunct. And note how the head of that is the VP, and it branches down to two other phrases. Another VP, which will then go on to lead to the head of the phrase, and we have a prepositional phrase, and that would be the adjunct itself.
And since as Michael well said, adjuncts are syntactically optional structure. Okay, the adjunct rule uses recursion. Okay?
Yes.
Because it's you know, if you add an adjunct to a VP, you still have a VP. Okay, and then you can so you can only have one complement. Like needs the paper. There's one structure that could fulfill what that could be in the position of what is needed. Okay, but adjuncts or modifiers for that verb phrase could be limitless. Okay, John needs the papers for tomorrow. In order to give them to somebody. So I guess going on and on and on. Okay? So there's no syntactic limit to that.
Yeah, it's easiest to see when you're talking about like position. You know, we could always be more specific about where something is in a spatial area. Like, you know, it's on the desk inside of the room that's outside of the house, blah, blah, blah. And you just keep describing location like that. So that's how we see adjunct play a role.
That's how we fulfill the discrete infinity of language.
And lastly, we see the specifier rule. So this is kind of what I was talking about, where I said we will see more important ways that specifiers play a role in syntax. So we will see later on a rule called the extended projection principle that states that the tense phrase always will require a subject, or sorry, a specifier. Sorry, the tense phrase will always require a specifier. But what does that specifier do? Well, you can see that as like the subject of the sentence, right? So in this case, this sentence says John needed the papers. John will be seen as the subject. And so, John would be seen as a subject, and that would be expressed then in the specifier position of the tense phrase. Note that to denote a specifier, we have that the head is a TP, and it branches down to the bar level of that phrase, so it's a T bar, and then the specifier itself would be the sister. So we have the specifier is the DP, and the sister is just T bar, and that's where the rest of the projection continues. So far, any questions about how this specifier rule plays a role in all of this?
Yeah, the specifier, what just, it's like, yeah, typically, as example here, we can think of it as the subject of the sentence, but we'll see that actually it works as the subject of other things. Yeah, not only sentences, but it could be of even noun phrases. Like you have, for example, the Roman conquest of Gaul, you know, like from history, you know. Okay, so if you think that's a noun phrase, but you see that conquest is actually very similar to a verb, you know, in terms of its structure. Okay. Okay. So you see, there's an analogy between the Roman conquest of Gaul, as the Romans conquered Gaul. You see, if you turn that into a sentence, you see that the Romans is the subject of the sentence.
Oh, yeah.
But in a noun phrase, it would be the Roman conquest of Gaul.
Yeah.
So Roman is basically the same, it's a specifier of that noun phrase. Okay. So if we understand subject in a more wider way, not only of sentences, but even of other type of structures like noun phrases, we may think of specifiers as that subject.
Are there any more questions before we continue on?
I'm sorry to give you interruption, but
What is what?
T.
T. So the T represents tense, right? So you can think of that as like the time. Note how the head of T is no plus past, meaning that this is showing the sentence in past tense. So that verb need, when we say it, is actually expressed as needed, right? Because it's that verb expressed as past. I think I did the S thing again. Yeah, I did the S thing again. Yeah,
Oh,
you're
you
right.
have a thing with the third person
Yeah,
singular.
it just completely passes me. I'm sorry. You know, it's the procedural knowledge taking over.
Needs it.
Yeah.
So, yes.
Yeah, I think if I use more third person singular, I think it's gonna persist, and I'm sorry about that.
And why is your T empty? Shouldn't it be ED?
So we say that the null past, the null plus past, whatever V category, like the verb, auxiliary verb, whatever it calls in, it will have a particular form, right? So in this case, and that's expressed in like its data grid. So for example, this null plus past will call in a V category in preterite form. So that would be, the need would actually have ED there, right? Which is why I was saying before that like I should put ED there, because it's supposed to call the preterite form, right? So that is my fault, but yeah, it's supposed to say
And the
ED.
verb just with needs.
Yeah, I think that's gonna persist. I'm sorry about that, but trust me, in the previous draft, the problem I had was that all the T's and like all the tense phrase heads and all the complementizer phrase heads, I didn't put the T for phrase, so it was even worse. But that's just a disclaimer. That needs is supposed to say needed, for reasons that are out of the scope of this presentation.
Oh,
But
I see that.
yeah, because it's supposed to be past, so it's needed.
Or you can imagine of it as just the stem of the verb. Okay, so the fact that we have actually two different syntactic categories, T and V. Okay, so V is like let's say like the lexical core of the verb, okay, which will be represented by the stem of the verb. And then the tense, you may say that is morphologically realized as the ending, as the suffix that will mark tense and agreements and that type of stuff.
Entonces, por los dos árboles van a tener el verbo como tal y donde va con el te podemos saber si es la forma de la era de la.
Yeah, there are two ways, but this is beyond the scope.
Yeah.
Pero el beneficio de tener el tense separado es que cuando hay un tiempo perifrásico, como en inglés will, need, entonces aparece en ese espacio y no tiene que juntarse.
You see that in many languages, en muchas lenguas, tense, o sea, es una palabra aparte. It's lexicalized, like the future in English. Okay, so the future is not in English. Is not a suffix of the verb, as we think of it in Spanish. Okay? It's actually a lexical unit independent from the verb.
Can you have multiple ones, for example?
So John will need the paper for tomorrow. Will be a good example there because you have actually a word that is realized under that note, that T note. Okay, John will need the papers for tomorrow, for example.
And
Yeah,
So there's only one tense.
right. Yeah, it will be here. Will be here.
So it's not really like the temporal information of the sentence, right? Like,
It is.
It has tense information because will is the lexicalized form of future tense in English.
what if, so
El tiempo puede parecer morfológicamente como una palabra o como una palabra separada de por sí.
Claro.
En español tú tienes los dos.
Claro.
Puedes hacer va o va a ir. Right? Both of them are future.
what if you have an if style sentence? Depending on which case happened, you can either have something in the past, like something didn't happen, therefore I can't do this thing in the future. So I need to receive this money so I can buy whatever tomorrow.
So those are like two.
If you need,
Those are bad sentences.
if you say I need to receive the money, at least about I need, there will be present
Okay, yeah.
because that verb is in the present tense. So when we call here tense, and this is a good, esa es una buena pregunta. Cuando hablamos de tense, we're talking about grammatical tense, okay? Not physical or dimensional tense, okay? Because actually there's no a correspondence between grammatical tense and physical dimensional tense, as we understand in physics, that we say present, past, and future, okay? That actually doesn't work in natural language. Because when I say, cuando digo, I live in Mayaguez, okay? Yo vivo en Mayaguez, okay? Es presente, okay? But that's not something that is happening only in this instant, okay? When I say yo vivo en Mayaguez, me estoy refiriendo a un estado que se ha prolongado, no es de un instante, es de un intervalo, y en física un intervalo va a tener, de ese intervalo solamente un instante es presente. ¿Ya? O sea, ese intervalo obviamente va a coger parte del pasado y probablemente parte del futuro también. ¿Ah? Sobre eso dice, sí, yo voy mañana a tu casa. You think that is past, present, or future? Huh?
Future.
Yeah, you think that.
Wait,
We all think
wait,
that,
wait.
but the verb is not in future, it's not, el tiempo verbal no es futuro.
It's present.
Sí, exacto, sí, yo sería, yo iré a tu casa mañana. That is grammatical future. ¿No? I'll go to, exacto, sí.
En inglés también puede hacer.
Pero puede ser, I'm going tomorrow.
Pero una
I'm going
pregunta,
tomorrow es presente.
Adiós, Naida está ahí.
Sí,
Hello.
Naida está ahí.
¿Me está escuchando?
Sí,
Estoy
Pedro
escuchando
está-
aquí.
Ya está Pedro aquí.
¿Cómo está Pedro? ¿Cómo están? Pedro, qué bueno que verte. Estás esperando por Kenny, ¿verdad? Pedro, ¿estás esperando por Kenny?
Sí, estoy.
Ah, ok. Bueno,
El
la
inglés.
pregunta que le estoy haciendo, yo creo que va dirigida a Fernando. Fernando, él está hablando de que está el presente, pasado y futuro. Eso es parte de lo que hay que programar en el parser, ¿correcto?
Bueno,
Fernando, ¿me está
por lo menos lo que, o sea, lo que quería decir, aunque no se entendió, es que en el lexicón, sí, o sea, tienes que tener, bueno, si lo hacemos en inglés es más fácil, en español es más complejo, ¿verdad? Pero sí, o sea, tú tienes formas verbales, ¿verdad? En inglés que ya están marcadas para tiempo y persona y número, ¿no? Así que, por ejemplo,
Correcto.
needs, N-E-E-D-S, solamente tiene la opción de ser presente de indicativo, o sea, gramaticalmente presente de indicativo y tercera persona singular. O sea, no puedes usarlo de ninguna otra manera, ¿verdad? ¿Verdad?
También lo que pasa es que estoy tratando de pensar, cuando estoy escuchando a Michael hablando de la teoría, cómo es la programación, porque cuando vayamos a hacer el parser, la programación tiene que estar atado y va a ser diferente en inglés y en español, ¿correcto?
No necesariamente, yo creo que las reglas sintácticas no, va a ser la información del lexicon, porque en el lexicon...
O sea,
needs,
eso se inserta en el
por ejemplo,
lexicon, se inserta en el lexicon.
Exacto, eso es información de la unidad léxica. O sea, el parser tú le pones reglas que esencialmente lo que van a hacer es unification, ¿no? O sea, hacer agreement entre los rasgos de diferentes categorías y lo que va a usar es la información que está en el lexicon.
Dentro de la programación, el único caso especial en cuestión de usar los items del lexicon va a ser el futuro, que tendría que usar el will y atarlo con la palabra, como en el ejemplo de need. Entonces necesitamos esa palabra nula, por decirlo así, en tiempo, para...
En inglés will, por ejemplo, tú dices.
Sí, para el futuro.
Exacto.
Sí, pero lo que pasa es que estoy
Ujú.
tratando de pensar, cómo es que se van a atar. Y esto nuevamente, probablemente Fernando tiene la mente clara, pero yo no. ¿Cómo se va a atar la parte que es de la teoría de X barra, que es la parte closed form de la solución, con la parte de inteligencia artificial? O sea, ¿cómo es que tú atas una cosa con la otra? Porque la de inteligencia artificial es una búsqueda y el otro es las reglas, ¿correcto? Yo voy a hacer una búsqueda y voy a hacer narrowing down de la búsqueda que voy a hacer, porque solamente voy a buscar aquello que haga sentido de acuerdo a la teoría de X barra, o es lo contrario. Yo voy a hacer una búsqueda y después le aplico las reglas.
De hecho, Michael habló de eso un poquito en la clase, en la reunión pasada, ¿verdad? Sobre eficiencia.
Yo no tuve.
Exacto, sobre la cuestión, el paper de Sandy Way Fong de eficiencia. Y precisamente es la diferencia entre un paradigma puramente declarativo, donde yo genero todas las formas, todas las combinaciones posibles de esas palabras y después voy aplicándole los filtros sintácticos para descartar, ¿no? Esto obviamente, o sea, va a resultar, te va a dar, pero es computacionalmente bien ineficiente porque tienes que explorar absolutamente todo el espacio posible de búsqueda, ¿ok? La opción, o sea, la alternativa que es la que presentó Michael, que explora Fong, es la de entonces utilizar, o sea, en minimalismo, ¿verdad? Ir construyendo localmente. ¿Qué yo puedo unir que satisfaga las propiedades sintácticas que tienen las palabras que estoy uniendo? Y cuando tenga eso, entonces busco, entonces uno lo próximo, voy merging, o sea, binary merging, ¿no? Cojo dos elementos léxicos y creo un syntactic object con dos elementos léxicos. Ese syntactic object lo voy a unir entonces con otro lexical item, y entonces ahora tengo uno de tres, ¿no? Pero cada vez que haga eso, o sea, no voy a hacer cosas para descartar, voy a ir haciendo las que cumplen las posibilidades. Y si hay más de una posibilidad de hacer eso, pues entonces ahí es donde se generan los diferentes árboles que indicaría que hay ambigüedad estructural. Así que es la idea de
Correcto.
aplicar este symbolic AI, pero no de una manera, no de fuerza bruta. Que sería crear todo.
No es brute force, es buscar el algoritmo que...
Am I right?
Yeah, yeah.
Okay.
It's bottom up from top.
Déjame asegurar que los estudiantes saben que la semana que viene va a estar Sandy Way Fong con nosotros. Y quiero asegurarme de que llegan a tiempo o que ponemos la charla de Sandy Way a 1 hora.
Sí, lo que pasa es, ¿sabe por qué fue a las 4? Porque que Sandy Way tiene clase. Como hay 3 horas de diferencia, él tiene una clase, ahora no sé qué hora es, pero es para que pueda estar 1 hora, 1 hora y media con nosotros. La única manera era adelantarlo un poquito, a las 4.
Ok.
Sí,
¿Y a las 4 la gente puede o no puede?
Yo pregunté, yo sé que sí.
I can put it in the group
Okay.
chat.
Yo creo que va a ser bueno para Iván. Iván es el que siempre puede antes, así que por lo menos sí. Pero sí,
Yo no veo a Iván, yo no veo a Iván ahí, pero está bien.
no, Iván no está aquí porque hasta ahora él tiene clase. Él está libre
Ok,
hasta las 5.
está bien.
Así que
Pero de
4 o
todas
5
maneras, para
horas.
que sepan,
Ujú.
sí.
Sí. Pero Naida, ¿entendiste lo que, o sea, no se respondió tu pregunta?
Sí,
Sí, ok.
sí.
Lo
sí, se
interesante-
respondió mi pregunta. Gracias.
Sí, lo interesante en cuestión de tiempo, y voy a usar, en inglés voy a usar la distinción tense versus time. O sea, grammatical tense is not time.
Se
¿Ok?
le dice aspect.
¿Ah?
Aspect, lo que estoy diciendo.
No, o sea,
ya.
time, bueno, sí, un poquito, pero
That too, but like,
aspect tampoco es time.
Yeah, so
Yeah,
there's tense
nada es
time and
time.
aspect.
Exacto,
Tense
sí.
time and aspect.
Exacto, pero para, o sea, por ejemplo, fíjate que yo puedo decir, John needed the papers for tomorrow. John needs the paper for tomorrow. John
I'm gonna be
will
thinking
need the
about your
papers
comments every
for
time I make a
tomorrow.
presentation
¿ok?
now. Every
que-
time I see the yes, I'm gonna be like,
En cualquiera de esos casos, ¿ok? Si tú piensas en términos de interpretación,
It
¿verdad?
doesn't keep bugging you.
Uno piensa en futuro por tomorrow, ¿ok?
There you go.
Pero fíjate, en cada uno de ellos, el grammatical tense es
I
distinto.
correct.
¿verdad? Ok, o sea, John needed
How
the
I need to do
papers
for the
for
rest of them,
tomorrow.
right?
Fíjate que es, aunque era for tomorrow, he may no longer need the papers because the verb isn't in pretérito. He needed the papers for tomorrow. It doesn't say what's happening now. A lo mejor ya no los necesita.
Bueno,
¿ya?
mejor todavía lo
Y eso se
necesita.
da porque por tomorrow viene un complemento, se lo puedo arreglar.
For tomorrow es un adjunto.
Sure.
Exacto, es un adjunto.
Sí.
Pero el adjunto, por ejemplo, yo no puedo decir, bueno, puedo decirlo, pero es metafórico. John will need the papers for yesterday.
I needed those
You
papers
may,
yesterday.
ok, pues, los necesito para ayer, ¿verdad? Pero es de una manera metafórica. O sea, you are not literally meaning that you will need the papers for the day before. The other, ¿ah? Or in that case, you say necesitaba los papers. He needed the papers for yesterday.
And we're gonna get
Okay, if you are, if you're meaning exactly what you want to say, okay, when you say I need those for yesterday, o los necesito para ayer, you are trying to convey urgency, but it's not literally that's not what you mean. Okay, so it's weird because that in some would be like incoherent in terms of interpretation because there's the tense of the verb would not match the time information of the adjunct, okay? But we make sense out of it because we understand it metaphorically, not literally. Okay? Cuando dice los necesito para ayer.
So, gramatical aceptable porque la no, entonces no tiene esa conexión con.
No, exacto. O sea, hacemos uso de este equívoco, ¿okay? And this is pragmatics, okay? Okay,
Dark room.
if he is, okay, if the speaker is making sense, okay? That's one big assumption in pragmatics, ¿verdad? Que los hablantes están cooperando en la conversación, okay? O sea, que no están diciendo disparates, ¿verdad? Okay, if the speakers are cooperating in the conversation, okay? Then there's something that the speaker wants to convey by using an adverb with that refers to the past. Okay, when he's talking about something that needs in the future. Okay, and that's where we understand that, with that metaphor, as the past means urgency. Okay, no se refiere a tiempo pasado, ¿verdad? Sino a la urgencia. But that's beyond the scope of what tomorrow or yesterday means. Okay, so that's you entiende. O sea, lo que quiero es o sea, lo que estoy tratando de decir, a lo mejor no lo estoy logrando. Sí, tienes para que puedas entrar. Lo que quiero decir es que nosotros hacemos eso automáticamente, ¿verdad? Pero hasta esa versión tan fácil, ¿verdad? Es un poquito retante en términos de. Sí. No, I don't think so.
It
shouldn't.
Porque el
It
adulto no tiene la conexión gramatical.
It shouldn't, unless we program some kind of unification between between time information in an adjunct and the tense information in the verb, but we'll have to code that. I don't think, I think that'll
And also,
be
I feel like that's more interpretation than
difficult and
grammatical,
risky.
so.
I don't think machines can do that right now.
No, that's more.
Pero es interesante lo que es interesante, porque por ejemplo, si yo digo, no, actually, it's kind of independent. I needed that for tomorrow. I can say that.
Yeah, John needed that for tomorrow, but now he changed it for the day after.
And I will need it for yesterday. We can, it sounds
No,
strange.
I don't like it.
You don't like it.
No,
Interpretively
I will
or
need it for
grammatically?
yesterday.
I will
No.
need it for yesterday. Not even as an idiom, not even as an idiom. Como el tema que nos dio para ayer.
I needed it yesterday, or I
No.
needed-
Not meaning that I needed them yesterday, but I need them now as soon as possible. In Spanish, we have that as an idiom, como una expresión idiomática. No
Something
es para
about it
ayer,
doesn't sound right.
meaning, tú sabes, ahora
Podría
mismo.
ser como que,
That
Do
has to be
you-
a thing that-
I'm not native speaker of English, so I don't know
John needed
that.
those papers.
no,
No, John
conversacionalmente sí saldría una oración así, sería como algo pues
John will need those papers.
John wants those papers for yesterday, is how I would say it.
Yeah. With the
I
present,
want
it's
to,
fine.
but then I will need
Yeah.
the material.
Yeah, I needed those
for
papers
yesterday,
yesterday.
algo así.
There you go.
Yeah.
The thing is that
Or
the
I need those
sentence
papers.
is, the sentence is grammatical
Yesterday.
from the standpoint of syntax.
That's
Okay?
Yeah, I
We
feel like
only
that's like
struggle with it when we
who's
try to
trying to
interpret
be
it and
funny.
understanding
Yeah.
based on our
Further you
knowledge of the
go,
world.
Por eso
Okay?
la pregunta
Although, as you see with the next presentation,
I
there's
will
some
need
crazy
them
stuff.
yesterday. is not-
It should. Lo deben aceptar. Exacto.
El apunto no tiene
Exacto. Nuestro país por ahora no tiene grandes capacidades de interpretación semántica, ¿verdad? O de pragmática. Así
No,
que
no.
debería aceptar todo aquello que sea sintácticamente posible.
Mhm.
Then we may, en otras fases. Hola, ¿qué tal?
All those green ideas should be fine.
Houston, yeah, Fernando, yeah, and Michael is giving us a presentation on I'm sorry they had to do syntactic theory today.
I do it on stuff, so I'm always interested in more of the linguistics.
No, he makes it interesting.
Flattered.
Okay.
But, so, anything else that we want to go over this, or are we ready to move on to the next part? Ready? All right. So this is just more of this preliminary terminology. One last feature that we want to mention is the projection principle. So here it states that the properties of a particular syntactic head is expressed at every one of its projections. Remember the projections being the phrase, the bar, and the head, right? So like, you know, TP, T-bar, and T-head, right? The example here kind of shows this off pretty well. So we think of the word the. The is a determiner. And we know that the is a definite determiner. It like defines a particular, say, entity, right?
Mhm.
So that property plus definite, right, will carry on all the way up to the DP, right? And so there are certain properties that need to match for certain like meanings to be interpreted, and that's why we have that the properties of the head carries on through the bar level and through all the phrase levels that are in charge of that head, right?
So what you mean is that any noun phrase that have the determiner D would be a definite.
Exactly. So if I have like the dog, then we have that the is definite, right? And then the phrase that it encompasses, so the dog, that whole phrase is also definite.
That's what plus definite means.
Yes, plus definite means that it is definite.
Definite.
Of the DP have plus.
It's like the whole DP phrase that is headed by all of that is definite.
Yeah, when we talk about definite determinate phrases and noun phrases, we're talking about that feature of the determinant. Es como en español el o la. Okay, so when you have a noun phrase with el, well, there are other
Don't worry about
possibilities
gender,
with
it's
that,
No,
right? What is this?
The Spanish needs LL pretty much all the time. English doesn't need the or
Yeah, but it's that, but you need something to make it definite.
Yeah.
It's that I bought, huh? Exactly.
It's also the
Yeah, but let's say that we're talking about singular for now. Ella, exactly. So if we're talking about singular, you mean you can say that there's a difference between the cat and a cat. Okay? If you say I saw a cat, what cat are you talking about? Anyone. right? You say, I saw the cat, okay? You may say that to somebody that you have been talking about a certain cat before. Otherwise, the person will say, what cat are you talking about? They say, I saw the cat. What cat? ¿Verdad? ¿Qué gato? Right? Because when you say the cat, it's, you are specifying one in particular. Yeah, a particular one. That's what definitely is.
There is one thing in terms of scope for determiners in Spanish versus determiners in English. And it's with the definite definite generic distinction, there's a mismatch.
We're not talking about the generic yet,
Yeah.
because but you have it in Spanish too.
Yeah.
El perro es the cat is a four-legged animal. El gato es un animal de cuatro patas. Are we talking about one specific cat? Well, one particular, no, that's a generic, but that's another animal.
But then in English, you don't get the there.
No,
I
you say
had cats.
dogs or cats, you use plural.
Yeah.
But in Spanish, you have a generic.
Mhm.
Sí, sí.
Alright.
But when you talk about the mammalian nervous system, that's a definite expression, but you're not talking about one particular thing. Okay.
So just really quickly, just remember the projection principle just states that whatever the head of a certain phrase has, all of those properties are then expressed throughout the entire phrase that it heads, okay? So
That's why.
that is true for any property of any head for that particular phrase. So if it was minus definite, like a cat, then the whole phrase is minus definite, okay?
You can think of it very easily. The only possible head of a verb phrase has to be a verb. Because in order to be a verb phrase, it's because it's the projection of a verb. Okay, so any structure has to be the projection of a head. Okay, and the projection will have the same category as that head. Yeah.
All right, and so we come to what we wish was the syntactic component, right? Which is, you have the lexicon, the syntax takes in the lexicon and uses these X-bar rules to form all of the possible sentences. And from there, we can make grammaticality judgments, right? That would be an ideal world where we just take words, we put them together and boom, we're done, right? And so now we're gonna go to why we can't do that, right? And we're gonna do that through theta theory, right? I've stepped up my game a little bit in this one.
Wow.
But
Yeah, your computer can't process your game right now.
so remember how before in our previous presentation with theta theory, we saw that sometimes we encounter words that require certain types of phrases to be complement, not just any phrase. But with our X-bar rules, it makes it so that anything can be a phrase or a complement or an adjunct or a specifier of anything, right? There was no limits. So it was super, super powerful, but too powerful, right? It over-generated. It made sentences that aren't grammatical, and we don't want that either. So we need a way to kind of take it down a notch. And this is where theta theory comes in. Here we are seeing what is called a theta grid. This just pretty much has all of the information that is found within that word in the lexicon. And it says, I need this, I need that specifically, and I cannot have anything else. So there are four main levels to see in the theta grid. We have an argument structure. This is essentially how many things it needs in order to be complete. In this case, there are three. We're almost never going to see more than three. One could make an argument that there's like some words with four, but that's a whole other thing. But really, we're going to see 3, 2, 1, or possibly 0, right? We have what is called C selection. This is selecting the specific type of phrase, right?
Category selection.
Yeah, the syntactic category, right? So in position I, right? In position I, it needs some phrase X, right? And it needs to be an XB and it can't be anything else, right? If there is something else, it's ungrammatical. In position J, we have the same thing for Y, and in position K, we have something for Z. And we'll see an example of how this works a little later. The third thing is what we say theta structure, where this is where the theta roles come in. Remember theta roles like agent, patient, theme, et cetera, et cetera, et cetera. And this is also where we see the distinction between external and internal. External, you can think of it like the subject, and internal, you can think of it like the rest, right? And then we have S selection for the semantic type. This kind of tells you like what kind of semantic thing it is, kind of. It's not as important. It is really important, but it's less relevant to what we're going to present today as C selection. So like that's where we have our entities, our relations, and so on and so forth. But that's more encompassed within the semantics, right? To see an example of this in action, we have the sentence, Mary placed the engagement ring on Amy's finger, right? We have that Mary is denoted as the argument I, the engagement ring as argument J, and on Amy's finger all as argument K, right? Because place, as we've seen the theta grid, requires 3 arguments. And so all 3 are satisfied, which is step 1 for having a grammatical structure, right? So all the arguments are there. Now we have to check to see if it's the right phrases. Well, it says the first one needs to be a DP, and sure enough, Mary is a DP, so we're good on that end. J needs to be a DP, and we see the engagement ring as a DP, we're good on that end. And K is a prepositional phrase, or needs to be a prepositional phrase, and sure enough, it is, because it's headed by the preposition on. If you need to move, just let me know.
No.
So C selection also satisfied. Now to check the theta structure, right? Well, it says that the argument I needs to be an external argument, so it needs to be placed as the subject, and it needs to be an agent, agent/source, right? You usually see this as agent. A lot of agents tend to be in this external argument position. And sure enough, we see Mary as the agent of this sentence. Mary is the one placing the engagement ring. So far so good. We see that J needs to be a theme. The theme is the thing being done by the verb. So in this case, place is the thing being placed. And sure enough, the engagement ring is the thing being placed. So we have that part of the theta structure is good. And lastly, we have the goal, the prepositional phrase needs to be a goal. This is where the ring is going towards. And in this case, we have on Amy's finger, that is satisfied. So that part of the theta grid is also good. And the last one, we need that I and J be entities, and that K is a property. Mary is an entity. The engagement ring is also an entity, it's the ring, right? And on Amy's finger is a property of the engagement ring, because that is kind of like describing something about the engagement ring. In this case, its location or its future location, or I guess past location, right? So sure enough, everything is satisfied. Because the whole theta grid is satisfied, then that means the argument structure for place is grammatical, and thus we are good. Yes.
Is it always the verb that requires the arguments?
Not always.
That's the maximum. That's the maximum number of arguments that a predicate needs.
Yes,
It
and
has 0, 1, 2, or 3.
and if I recall, every phrase has one of these. Yeah, but it's easiest to see with verbs, because verbs is like when something's missing in a verb, you can really see it.
And you can have more than one theta grid for a single sentence or a single one.
So each lexical item will have its own theta grid. So it's independent of sentence.
Theta grids are part of the property of the lexical item. So this is not the theta grid for that sentence. It's the theta grid for the verb place.
Yeah.
Which means that every structure in which the verb place is contained will have to satisfy that property. Okay?
So,
You just using that sentence as an example.
yeah, and if every token has a valid theta grid, then it's a valid.
Yes.
Yeah.
Exactly.
Mhm.
Yeah, when we get to the next presentation, you'll see how that plays an important role in checking grammaticality of sentences.
If you eliminate any of those 3 phrases from that sentence, you will notice that there's something anomalous with the structure. Like Mary placed engagement ring.
Either that, or you would have to fill it up with context.
Exactly.
But the thing is, you have to fill it up.
Exactly. Yeah. Or Mary placed on Amy's finger.
And will the parser be able to detect the context in the case where, let's say, the third category is?
That is an interesting question. I would
What?
like if let's say Mary placed the engagement ring, right? But you would need context to fill up the last.
No, it
Argument.
would probably mark it as ungrammatical.
Yeah.
Remember that it's parsing a sentence at a time. It's not dealing with context. So this
Yeah.
is just.
Yeah, so
it's
that would
one
be,
sentence.
if you were to make like a whole
Yeah.
big machine that could actually converse with you, that would be something dealt with later in the process. But
You will have to build a knowledge base in order to use context. If we're parsing sentences.
Primero para secciones a ver.
I replaced it.
Oh yeah, but Mary placed it.
In that case, the context establishes what Mary.
yeah, the pronoun.
Yeah, But it may not generate a tree because it, according to this, it will detect that there's one argument missing. Place it where? Yeah. But if you say Mary placed it there, it should, yeah, that's okay. Because actually that argument, the third argument, it could be an adverbial phrase, it could be a prepositional phrase or
Yeah.
adverbial phrase. Yeah.
In this case, the verb needs three arguments.
Be them realized as full phrases or pronouns or whatever.
Because there are certain verbs that may have two or three arguments.
Yeah, we're talking about that, I think, in a previous discussion, that there may be lexical items that may have more than one theta group.
Yes.
Okay, like for example, I will always use the example of drink. Okay, usually, drink requires two arguments: who drinks and what. Okay, but there's a use of to drink in which you only have the external argument. Yeah. And that actually has a slightly different meaning, no? When you say he drinks, okay, you're just talking about alcohol, okay? So drink, so we may say that in those cases, actually there are two slightly different verbs, okay? One, the drink that is transitive, so said that the drink that has an argument, an internal argument, and the drink that is intransitive, okay? The drink that doesn't have that complement, which means something more specific, drinks alcohol, okay? And the same thing with the verb to live, live or vivir, okay? Vivir can be intransitive, no internal argument. So he said, he lives, that means he's alive, okay? But there's one in which you say he lives in Mayaguez. That is, you don't mean that he's alive in Mayaguez. No, you say that he resides, no? So you see, because they're so similar, we think of them as the same thing. They're different verbs, but they mean different things. They're just homophones, okay? And they have different theta grids, okay? So if the lexicon contains the different possible theta grids for those for those verbs, then it will understand, it will check as grammatical. He lives or he lives in Mayaguez, yeah, because it's using two different lexical items for each one of those sentences.
Is that for like each entry in like a dictionary, for example?
That will be in the lexicon, yeah. You have one entry for live, in which there's only one argument, the external argument. Okay?
So each lexical entry has its own thing.
Each lexical,
And when you
exactly.
parse it is when you try to figure out.
Because that theta grid is what's telling the combinatorial properties of that word. Okay, and the combinatorial property has to be satisfied, otherwise the structure is grammatical nonsense. Supposed, yeah, in theory.
And when you're parsing, I guess you would have to check each token for each possible lexical entry and then see which ones are satisfied.
Right.
Given the, so it's very complicated.
Yeah, syntactic structures are like jigsaw puzzles,
Yeah.
where each piece has to perfectly match.
And there might be more than one. I guess there might be more than one and so on.
Yeah, those are the cases of ambiguity.
That's right. Okay.
Exactly. When there's more than one way of doing that perfect match.
Alright.
That's
And sorry.
¿Puedo hacer una pregunta? Can I make a question?
each of you, of course.
No, but because I am, I think that maybe Fernando or Michael or somebody has worked on software previously that has been doing similar things. I mean, the constraints are, I think in the previous slide, correct, Michael? The previous slide? No, two previous slides. El otro, el anterior, el 13, 12, 11, 11.
This is
So the
11.
constraint, 11. So is the constraint is the lexicon, the ex-variolitur, the grammaticality judgment, and the rules of theta theory. Is that right? Those are the four
We're gonna
constraints that-
update this along the presentation.
Yeah, this is a wishful thinking slide. Okay, so if that were it, okay, we probably would not be having this conversation.
Está bien, lo que pasa, Hilton, es que en este momento yo tengo miedo, porque son muchas cosas que tenemos que programar.
No,
Y es
but-
bien probable, muy probable que el grande sí se te lo den. O sea, porque va en camino a que te lo den. Así que we need to deliver.
you know,
Porque
but you don't-
tener un grande CISE es bien crítico, es bien importante. Okay?
Right, but remember, this part is not very different from what Carlos already did. Okay, so his, the lexicon that he was using for that project, had all this theta grid information, everything.
Okay, so yeah,
And-
okay,
and
so that was
it's-
okay, that
it's-
was okay.
It's doable, it's doable, it's doable.
Es doable, okay.
Sounds worse than it is, well, it is, it's not, it is.
He referred to that as some category of for the
Exactly, the subcategory, exactly, the subcat is essentially this, the C selection.
right.
That's the subcategory, yeah, because it's called subcategorization frame or C selection properties. It's the same, just two different ways of referring basically to the same.
Yeah, and we're gonna see more of that later, but to further answer your question, Dr. Naida, as the presentation continues, we're gonna be updating the syntactic component. I think there are like 4 variations, and after the end card, there's even a 5th one for those who are interested in seeing it. And even then, in the next presentations, we're gonna compare this to a different approach to syntax so that you can see that there are more efficient ways of going about this than X-bar theory. But this is just to teach us about the terminologies and to get us used to what's going on and how the syntax works, so that when we do the big stuff or the other stuff, then it'll be much more familiar.
Yeah, Michael is doing what my students hate. to seeing that, okay, that we got to the we got to the goal, but no, we need more.
Ven esto que es fácil, esto lo voy a
I'm sorry, what?
The structure
Mhm.
is our refinement on the subcategory.
The subcategorization is part of the theta grid, essentially.
Yeah, it's they codify, yeah, they codify different information. Okay, for example,
But this is more specific in terms of establishing what kind of run should go where.
exactly.
So,
Lo que pasa es que el problema que yo tengo en mi cabeza es que el que tiene un martillo todo lo ve como un clavo. Yo miro desde la perspectiva de cuántas computaciones diferentes o qué tipo de algoritmos o qué cosas tengo que hacer, y ustedes lo están mirando de la perspectiva teórica, y en mi cabeza lo que yo tengo ahora mismo es una mezcolanza que no tiene ni pies ni cabeza.
Well, good.
Pero
That's
nada,
that's your
continúen.
Good, that's good. That's what you're doing.
el data grid se piensa, o que está, ¿cuál es el propósito del data grid en Spark? Darle identificarlo como gramático o no.
The theta grid will say if you right, because the parser is supposed to not only detect ambiguity, but grammaticality as well.
O sea,
So if I give a sentence like Mary placed on Amy's finger, I don't want the parser to produce any structure because that's nonsense.
So,
Okay.
entonces,
Besides grammaticality, I'm guessing meaning as well. So depending on the lexical token, you would have a different data structure, and then you get the, so for example, the S selection, you get like a specific, so this is the entity, this is another entity, this is a property.
Right, if that's in the lexicon, okay, that is information that we may not have to use for at least the S selection and the theta structure. We may not have to use it for the first for the first part of the project. But if we want to expand it, to do some kind of semantic semantic form, then we'll need that.
I think it would probably be more work.
What?
I think it would probably be more work to add it in later.
Yeah.
It would be more worth it, yeah, it's just that, do the entries as, if we know that we're gonna need that information at some point, just add them now. Okay, we'll use them, and then we'll write more code as needed, okay, but the lexicon is already done.
pero estaba pensando entonces en cuestión de programación. para identificarlo como algo gramático o no. O sea, no se quiere mostrar una estructura de algo que no sea gramático, pero la estructura tiene que guardarse antes de mostrarse y analizarse para ver si es gramática o no. O sea, la posible estructura. Porque entonces el data grid se puede usar como algún tipo de función que evalúe la estructura y use las reglas sintácticas para chequear. Entonces, existe esta conexión, hay un DP, hay un DP, hay un PP,
Yeah.
tienen las conexiones.
But that's what we don't. That's what we don't want to do. ¿Sabes por qué?
This is what happens when you don't scan your
Yeah,
words.
yeah, I know. That's why I don't like to do that, those in English. The thing is that that's exactly what we were talking before, that one approach is to generate all the possible combinations of the word and then scrutinize each one of those possible structures through this syntactic constraint. But that is a very exhaustive search through the whole space. Okay, so we don't want to do like partial trees of what at the end we're not going to consider sentences in order to check, because that's a lot of compositional resources that will lead to nothing. So the best approach would be to just start to make the combination. But if you see that something's lacking, don't even bother.
Pues exacto, como quiera, parte de la estructura tiene que ir construyendo.
It would exactly, but it would not go farther than the VP, because the verbal phrase for place will need those three arguments. So if you're not getting the third, one of those one of those arguments, it's not going to work again. No.
Is this a different approach to the minimalist?
Yes.
Composition? Yeah, but you don't need data grids for that, right?
There's a different way to go about it.
For them, yes. The thing is that the difference, basically, computationally, between principles and parameters, which is pretty much what it's being done here when we talk about X bar, okay? It's a more declarative approach where X bar generates everything, and then you go through syntactic filters. Okay, does this satisfy argument structure? Yes. Does this satisfy the theta criterion? Yes. Does this satisfy the case model? Yes. Exactly, it's brute force. And then you start to submit, to subject every possible structure to a syntactic filter. But that is brute force, because you have to generate, possibly hundreds of structures.
And I had another question about we can say that slide. How does the parser know when an argument could be implicit or has to be explicit to determine grammaticality? So, because I believe you said that for the K argument, it's not always the case where it's required. And for a specific lexical token, how does it have to be like rule-based, explicitly broke down that? I'm guessing it will get it from the lexicon, but so how does it know if an argument has to be implicit?
So are you talking about like when sometimes context can come into play?
Yeah,
to fill
but
up whatever.
remember, we're not
Or are you
using
talking
context
about-
yet. We can't use context yet because we are analyzing sentences.
But so if it doesn't have argument 1 or argument I,
Non-grammatical.
you can determine it's non-grammatical. But if it doesn't have argument 3 or argument K, you can flag it and say it might be grammatical or might not.
We would use a
Mary
like
plays
a-
engagement ring like that.
It's like
Mary plays engagement ring.
that's it. Mary placed it.
No, Mary plays it.
Yeah,
You
yeah.
have the argument. That's not implicit. That's explicit. You have.
No, but you don't have the third.
Oh, Mary plays it. Yeah, that's not grammatical. That should not be. Mary plays it.
Is there not a grammatical?
Not according to this.
So a token has to have. It can't. There
Even-
can't be an instance where it
if-
has 2 and then another instance.
If
where it has
this is the only theta grid, if for the verb place in the lexicon, it would not allow for any sentence in which one of those arguments is lacking.
So again, going back to the
Not
lexicon, it has to be, the lexicon has to be exhaustive enough to where you can identify.
The sentence that you provide, for it to be parsed should have, the parser should recognize the three arguments in that sentence. Okay, otherwise it will not produce a structure.
You don't care about anything outside of the sentence, right?
Oh, well, you can have Mary plays the engagement ring on Amy's finger during her birthday.
But that's all within the.
Yeah, but that's an adjunct. Adjuncts are within no problem because adjuncts. Remember that adjuncts are just added by recursive rule. If you have placed engagement ring on Amy's finger, you form the VP. Okay. Now, once you have the VP, if it finds that there's another prepositional phrase like on her birthday, it just take it as an adjunct and then add on her birthday to the verb phrase, place engagement ring on Amy's finger, and then create a bigger verb phrase. Okay, so that wouldn't be a problem. What the parser rules are going to look for is that each one of those arguments are syntactically represented. If they're not, okay, so you may have Mary placed.
Antes de comenzar el análisis, esa información se saca del léxico. La
Y bu-
cantidad de argumentos, la cantidad de verbos.
Yeah, that the parser will have access to that.
Correcto.
Yeah,
Gracias.
exactly. But for example, when you have on Amy's finger, it detects the preposition on, and there should be a theta grid like this for on. Okay, because on requires one argument.
All of them are gonna have one.
Yeah.
Okay,
And they all
so
have
you remember
different,
that
like,
will happen for every.
grammaticality.
For example, the engagement ring, the requires one argument. You cannot have, you cannot have.
Does it on require two arguments?
No, one. On
Well, you can't, well,
Amy's finger is one argument.
Yeah, the thing is, other arguments can call for a preposition, but that doesn't mean the preposition is calling for that.
What
Yeah.
is interesting is that the position needs to be on goal.
Yeah, because you cannot, because with is that, and that's where theta theory comes from, okay? Because you need here a preposition that will have goal. So with it will not satisfy this. You may have Mary placed the engagement ring with Amy's finger. That should not. That's weird.
Why do you say English birthday?
On a place engagement ring on Amy's birthday. It may.
If it was my thing, I would.
It's a different-
Yeah,
the thing is you would
it may say it's grammatical.
But it's grammatically correct now.
Mary placed the engagement ring on Amy's birthday.
So it kind of
Mary
depends on-
placed the engagement ring
With Amy's finger. It's not grammatical, right?
on
No, that would
grammatical,
be-
not grammatical.
That will be adjunct because you're talking about manner, and manner in this case is completely optional. Note how we can talk about the placement of the ring in a certain position. We don't have to say how they did it.
Yeah. Remember?
We do it all the time. You don't have to say how you do it. You just kind of assume there's like a certain way of doing it.
Okay. Naida, ¿tú estás oyendo algo? Pues tú como una gallera.
Yo escucho todo lo que dice Hilton. Lo de Fernando se me hace difícil.
Naida, ok.
Escuchar a Fernando se me hace
Déjame si
difícil.
puedo enfocar esto aquí. Ok, un minuto. Miren. Ok, fíjense que cada una de estas, each one of these elements in the theta grid, is syntactically relevant for one reason. Probably, let's start the S selection for now, okay? If you have Mary placed engagement ring with Amy's finger, we don't want, that's not a grammatical sentence. We said, why? Okay, well, there's a third structure there, okay? With Amy's finger is a prepositional phrase, but then is the theta structure that is not actually realized, because with is not a goal preposition, okay? A goal with is a companion or instrument. That is the theta structure of the preposition with. Okay, with indicates instrument or comitative, is a companion.
How is this on something along the lines of
Yeah,
like, go with your father? Go with your father. Like, you see
That's
with your
fine,
father.
because go doesn't actually require an internal argument. Okay, go only requires a subject. He goes, okay? But because go has a different, go will have, you know, something like this. And then, exactly, it will have just a, well, go is a little tricky. It has an internal argument, but it actually, it's actually realized as a subject, okay? Where it goes. With the father is an adjunct. Grammar doesn't care about adjuncts. Adjuncts are freely attached. Okay? So the restrictions are with argument subject. Argument is is what the restrictions are really with informing phrases. Okay? Adjuncts adjuncts come for free. Okay? Just go with your father to your room, blah, blah, blah. It may not make much sense if you keep adding stuff.
Milton,
The syntax is not bothered by that. Naida.
¿me puede escuchar?
Se puede
Mira,
escuchar.
que la reunión es hasta las 6:30, correcto, porque yo
fue,
no,
perdón?
que si la reunión es hasta las 6:30, porque yo no he escuchado a Pedro y al invitado hablar tampoco. Te pregunto.
Creo que los acabas de escuchar. Naida lo escucha.
Que no tienen nada que decir.
Digo, yo siempre tengo algo que decir, pero no inteligente en este momento.
No hay problema. No hay problema, pues entonces continúa con Michael, porque Michael no ha terminado la presentación, ¿correcto, Michael?
Yeah, you know,
Naida pone orden hasta.
yeah, thank you. It's to give you an idea, we are now reaching 1/4 of the way. So it's gonna take us a couple sessions. But yes, so with this in mind, right, now that we have a better idea of the theta grid, we're gonna add this to our previous syntactic system, right? Before, when we just had the lexicon, the X-bar rules, and the solutions, right? Here, now we will say that there is a lexicon, and the lexicon is used with, the syntactic system uses the lexicon to produce sentences via the X-bar rules. But then once all those sentences are generated, right, it goes through this filter called the theta criterion, which is essentially just checking all the theta grids, making sure everything is nice and tidy. And if everything is nice and tidy, if all those features are checked and successful, then we say it's grammatical. This would be an ideal situation, right? Yeah, and this is definitely how everything's going to stay, except for right now. So, yes.
¿Qué caso habría que el X-bar theory clasificaría como gramático que realmente no es gramático y que el theta grid
Okay.
Cualquier cosa.
I got this one. So when I say something like the going, right? Think of it. It's just X-bar rules. All it does is says, let's say complement rule. You have a complement, you have X-bar, and it goes down to X and some phrase, right? Any phrase.
It doesn't really check anything, it just points.
X-bar by itself is free marriage. Esencialmente.
So now we're gonna look at some more information to see some additions that we have to make to this, which is if you read the theta presentation after the end card, all of this is there in much more detail. So we're just gonna say what is important for terms of this presentation, okay? So here's an example to consider. It rained, right? Question, what does it refer to? It refers to absolutely nothing, right? So why is it there? Why can't we just say rain? Why is that ungrammatical? And why is it that in Spanish, you can just say rain? Llovió. You don't need it. There is no equivalent of it in Spanish in terms of that. Like just some word that does nothing but allow for a subject.
Does this satisfy the theta grid?
No, not even. Look here, the theta grid for rain, what you call the subcategorization is just the verb itself. It requires nothing. And it's not that, oh, you can have whatever it wants. It's that it needs nothing as a complement or a subject. It needs to be by itself, right? And this is with a lot of weather verbs, like it snowed, it rained, it was sunny, right? Or stuff like that, right? So with our theta theory, like how do we account for this? Where does the it come from? Because think of it, if the theta grid didn't have an external argument, then we would expect that a grammatical structure would just be rain, because having it there is too much information and thus it should be ungrammatical.
So X-bar would say this is under.
X-bar would let this happen, but theta theory would say that it can't go through.
Exactly. This is the case where you have where X bar we say it's okay. Theta theory we say it's not okay. Brain doesn't need any kind of argument. Okay?
Yeah, and so
So
we
you
need,
need something to mediate in between those two principles.
so we need a way to kind of intervene somewhere between where the theta theory checks and where it is inserted. Right, or I think it's after theta theory. Theta theory needs to check it, and then it needs to be there, because theta theory says that there needs to be nothing, right? So nothing should be there when it goes through theta theory. Theta theory says, okay, we're good. Then we need to put the word it, right? How do we get around this? So we use a couple of tools. We use firstly what we say the expletive insertion rule. Expletive is a word like it and it rains. It's just a word that is syntactically obligatory, but doesn't mean anything, right? Think of the phrase, there is coffee. What does there refer to? Nothing, right?
But this is the case for generative. So when you're trying to generate a valid sentence, not when you're parsing.
Yeah, this is for generating the sentence. If you're parsing a sentence that already exists, the it is gonna be there. Right?
Yeah, and then
So it needs to, so for example, when it comes with rain, right, it'll recognize that rain cannot have a subject, right? And eventually we hope that there will be features that check, okay, well, it cannot be the subject, it cannot be referring to anything, or else it would be ungrammatical, therefore that it needs to be the expletive. And that's why it's ungrammatical.
But you can't use this because this is for when you want to generate.
This is more for generation. Yes, this is more for the theoretical side of things, but I mention it here because at one point in one iteration of this presentation, it was much more important than it is now. But I also do want to recover it just in case when we're doing the parsing to keep us aware of those pleonastics or the expletives like it and there and how they could be really finicky sometimes. So it's just to make it really present and to update our syntactic model to incorporate sentences like it rained. Okay. So the expletive insertion rule is exactly what you think it is. Put an expletive. That's all it does, right? If there is no subject, put it or there, and just make sure there's something, right? Now notice how not every language has this rule. Now, why could that be? One way you could think of it is that some languages have what is called a no subject, right? Where there is something there, it's just not pronounced. And some languages don't. The ones who don't still need a subject there, and that's where we put it. This is not explained in the rule. This is explained in what we call the extended projection principle, which means, or which says, there must always exist a subject, right? In Spanish, that subject is presented as the null subject, so it's unpronounced, and thus you can have jovial by itself. But in English, we don't have a null subject. Thus, we need to put a word there. In this case, it could be it could be there, or whatever null subject. We just gotta have something if there's nothing. Right.
That what Michael wants to say that in Spanish, and actually every language, but in this case, in Spanish, there's a word that has no sound. Okay, that is a word with no sound. Okay, and that is what that is what we call the null subject. Okay, so it's there. This a syntactic object with no phonetic matrix. Okay. So we think of linguistic things that we have to listen, hear them, or see them, but not necessarily. Okay, so they're syntactic ghosts.
It seems like a very arbitrary principle. You're saying it needs a subject, but there are cases where that subject is not.
It needs a syntactic subject,
It needs a syntactic.
which is not the same as a semantic
Es
subject.
como la sentencia de los sexos
Okay.
básicos.
Okay, if you need some syntactic object that satisfies the function of subject. Okay, in every language, every sentence in every language does that. Okay.
So this is just for, would this apply to the X bar tree? So
This
you
is-
have a null subject, so. it
You will
allows
have a
that-
subject. If the language, if for a certain language, say Spanish, there is a null pronoun within the lexicon, then that's what it will use. If the language is English, where there's no such thing as null subject, then it will have to use what's called an expletive pronoun, which are pronouns that will satisfy that subject requirement, but means absolutely nothing, like it in its rating.
And we'll see how this.
It is
how
not the
this-
day or the cloud or anything, okay? So remember that the traditional definition of a pronoun is a word that can be put in place of a noun phrase. Try to substitute a noun phrase for it in its rating. You can't do that because that only works for referential pronouns or pronouns that has semantic content. But the it in its range has no semantic content whatsoever. Okay, it exists only because of the syntax. Okay, so so this is a principle for syntax, not for semantics. Okay, so you just need a syntactic object that will fulfill the function of subject. So you know this is probably
Yeah, so, and we will see how this is incorporated into this principles and parameters. Yes, actually, this is actually really important to go through because this is what we will see throughout the presentation. The subject more formally is how we mentioned it before, how the tense phrase has a specifier, right? That specifier of the tense phrase is the subject. And what this projection, the extended projection principle is saying then is that in every single tense phrase, there needs to exist a specifier, right? A specifier has to be syntactically present in the tense phrase. If that doesn't happen, then the whole sentence is ungrammatical, okay? Yeah. So, and how is this incorporated into our system? So that means we need to update our syntactic system. So here's what we have now. We start with the lexicon. We have all the words. The syntax uses those words along with the X bar theory rules and makes its structures, right? Those structures are then filtered through the theta criterion, like we mentioned before, with the theta grids and satisfaction. If there exists a tense phrase with no subject, that is where we put a subject, right? In the case of English, if there is no syntactic subject present, that's where we will put it or them, right? After the theta criterion, because it already said, oh, this does not need a subject. We pass it through. Then it's like, oh, we do need a subject. We'll put it, right? Then it goes through the extended projection principle. This is where it checks that there is a specifier for each tense phrase, right? So it's like, okay, we check the tense phrases, they all have specifiers, good. If it's missing one, discard it, right? And after that check, we finally, ideally, get our grammatical structures, right? So, any last questions? Because now we're going from the review, this is all the review, and now we're gonna go to the actual thing of this topic, which is movement. If we're ready, then we're gonna move on to our favorite thing, some more problems with the current syntactic system, because we all love looking at those. So the rules are pretty good for the most part. They allow us to get specific verbs that require specific things and make sure that within a phrase, we can have different selections, like different verbs can select for different things, which reflects better how we construct our sentences. But now, sometimes we get them in the wrong order, right? And sometimes these relations are not reflected properly in the order of these words. Remember how we mentioned before that the complement rule states that the complement and the head have to be right next to each other, right? So then how do you explain sentence number one? Because if we take a sentence like, he has eaten today, right? He has eaten today. Has is calling for a verb. The helping verb calls for a verb so that it can help it, right? So has is surely calling eaten, right? But how is it that there's a not in the middle in there, right? How is it that we have this word that's kind of interfering with this complement relation that we expect the complement and the head to always be right next to each other? Or how about in a question where we have something like, are you okay? You can see as like there was a declarative there, something like you are okay, right? But now in the question, it's, you know, we switched where the R is. R is calling for okay, but now there's you in the middle, which doesn't make sense because the complement relation says that those two words should be right next to each other. So what's going on? Or how about in a WH question? WH words are just words like who, what, where, why, when, how. In Spanish, we also call them palabra cu, I think it is. You know, cuando, que, como, all that stuff, right? So how does that movement work? How is it that we have all these WH words that they always, or most of the time, end up being in the front of a question, right? What's going on over there? And in the last sentence, we see the apple was eaten by the kid. In that case, we have like a passive sentence, meaning we have a passive sentence, which is just a different form of a sentence. I believe we will go through that later, but for purposes of this demonstration, it's not as important to go through. However, we see eat. And with eat, we would expect that the complement is the food, right? And so we would expect that the complement and the head are right next to each other as the complement rule predicts. However, the apple is much farther away, and in fact, it's on the other side, right? It's not only not beside it, it's on the other side. Which is like, what? So, in short, now we have a system that cannot generate sentences that we want it to generate. Before, it created sentences that we didn't want it to. Now it can't create sentences that we want it to. So instead of over-generating, now we're under-generating, right? So it's a tricky thing that we need to solve. So before I continue, this is like an important thing. Everyone understand what the problem is, right? There are words that should call for other words. And based on the complement rule, they should be right next to each other. But they're not. And in fact, they could be arbitrarily far away from each other. Like with a question, like a WH question, like what? You could extend the question further and further and further via, say, an adjunct rule. And it's only gonna make the words farther from each other, which is not what we want. We want them like right next to each other. So how do we deal with this, right? And to demonstrate how much of a problem we're in, because you know this is not any small thing, we're going to compare two sentences. One that is grammatical based on what we have so far, and a sentence that this system that we have cannot generate. So here we have the sentence, you can fly, right? You can think of the CP in this case as just like the generator of the sentence, right? And so we have the CP generating the sentence. In this case, that's not a question, right? So minus Q, meaning not a question. And it's generating the sentence, you can fly, right? So far, so good. We have can in the tense phrase, can calls for fly, and you is the subject of can. So we expect it to be in the specifier TP, which it is, all great. But let's see, if we wanted to make that sentence a question, what would that question be? If we wanted to turn you can fly into a question, can you fly? I propose to you, if it ever wants to show up. Please. Oh my God, it pops up here, but it's not there. Are you kidding me? Oh no. Oh, it probably disconnected or something because it's not seeing the changes to the slide. Yeah, let me see if I can. No.
Michael, yo estoy viendo los slides.
Yeah, no, but it's not showing up here.
Ah, no se muestran ahí. No se muestran ahí.
Oh,
Pero yo lo estoy viendo, sí.
¿Tú estás viendo que cambien?
yeah, so it's probably the connection with this with the computer.
Sí,
to
yo
the TV.
estoy viendo los
Because that
cambios que
depends on the
Michael.
internet. Sí, eso está por AirPlay, está usando internet.
Yeah. You wanna try this here? Oh man, now all the drama is gone.
These slides are very descriptive, so I didn't see them before.
Yeah, what I'm gonna do is I'm gonna fix some changes because I know there's some errors here and there, and I'm gonna put them, all of these presentations will be present in the Google Drive.
It's too much.
Yeah.
Because they're very descriptive, so like beforehand.
Yeah, definitely it would, you're right, it's definitely something that it would be great to have before, but I'm constantly updating things before the presentation, so I thought I can.
¿Quién quiere ya que haga eso?
Eventualmente, cuando se vaya a programar todo
que ellos
esto,
entiendan que están fuera de
se puede
contexto,
coger
para que ellos entiendan cuáles son los objetivos de nuestro proyecto y para que ellos nos puedan presentar los objetivos.
Que nosotros tenemos un redesigno de objetivos.
la
Sí, sí,
regla,
sí.
no, porque esto tiene la regla
Porque están
y
perdidos.
por qué
Claro.
la regla no borramos por qué cuando vayamos a programar y podemos dejar llevar de presentación para ver cuáles son los pasos.
We can do like just kind of, what is it, something notes, it's like a thing online, where like instead of reading the whole book, maybe people like.
Spark notes.
Spark notes, yeah, we just do like the spark notes of the presentation. Kind of like the cheat sheets like we do in physics or.
Sí, sí, a eso mismo me refiero. Pero eso, anyway, se hace después.
Yeah, but really, that would be more important with the other presentations, because, this is
What
more
is
like
happening
background,
here?
but when we do minimalist program, when we do.
No pasa nada.
Right, they're gonna use these concepts, but we're gonna approach syntax in a completely different way, because it's better. But we need to present this, because just like, you weren't there in the previous.
Cuando él estaba en presentation mode, yo lo estaba viendo cambiando.
Es que como que se murió el televisor y el Apple Play y no hace nada.
Bueno, pero yo la conexión la veo. Quizás lo que se murió fue el televisor allá.
Sí, tú estás bien,
Sí.
sí, porque el PowerPoint.
Yo estoy viendo la presentación. El PowerPoint está ahí. Lo que necesitas es apagar el televisor y prenderlo de nuevo, porque parece que murió.
Sí.
Y by the way, hay un problema con la red en el departamento que ha estado pasando desde esta mañana.
No me diga, de verdad.
Oye, y creo que es
Yep.
algo. Creo que es la primera vez que pasa.
Ok, ahora sí.
Yo escuché algo.
Correcto.
I don't know, I've never heard it. I guess I never really paid attention.
Vamos a ver. Yo creo que
Oh, it is? Okay, there it is, okay. And
Exacto.
there's the big
Ya.
reveal, there it is, yeah. So yeah, so we have this sentence, yeah.
Okay, when there's a time that you can make it pause.
I mean, you can do it now if you want to.
No. Okay. Es que Naida suggested that probably we should talk a little bit about the project objectives so that our guests know why are we doing all this, you know, kind of legal stuff. Okay. Yeah. So welcome again. So we are actually the proposal actually Fernando, Naida, Christopher, and myself wrote for NSF. It's a proposal for we call it a hybrid architecture syntactic parser with neural lexicon. That's actually the title. Okay. What do we mean by that? Most most approaches to natural language processing are almost exclusively probabilistically based. Okay, got a big corpus. Okay, and then that will train some kind of neural network, and you know it will see patterns, and then it will recognize things. Okay, and that actually works. Yeah, that works. That works to a certain extent, okay? Because it may actually over-generate, okay? If you see parsers that are based only on neural networks like the Berkeley parser, you can write gibberish and it will produce a syntactic tree, okay? So it has no way of distinguishing what is real language from what is not, okay? So what we want to do is something that will actually be able to make that grammatical distinction. Okay, that will say, yeah, this is a good sentence, you know, good sentence in English. This is not a sentence, so I'm not going to produce a tree for that. The reason why we want to produce trees for that, for sentences, in part is because of the main problem that we want to address, or one of the problems is the problem of ambiguity. Okay, that it's a property of natural language. Okay, which is not found in any other formal artificial language, where there's no way that you can have in mathematics an expression that will an equation that will mean two different things to different mathematicians, okay, or different physicists, because those systems are those formal systems are not ambiguous. Okay, natural language, on the other hand, it is. Okay, it's not Spanish only, it's not English, it's all language. Okay, but the ambiguity is just in appearance. Okay, because when we speak, okay, or when we read, okay, we just our sensory systems only detect linear things. Okay? Sequence of sounds or sequence of words. Okay? But what linguistic theory tells us is that actually our mind does not process or interpret linear structures. Okay? Those structures are actually originate and are converted back into trees. Okay? So when we have ambiguity, it's because the same linear thing can be represented by two different tree structures. Okay? So if we want to detect ambiguity in an expression, the way to do it is, can you generate two valid syntactic trees for the same sequence of words? If the answer is yes, then you have an ambiguous sentence. Okay? So if the answer is no, you generate one, that sentence is not ambiguous. Okay? If you cannot generate any structure, then that's not even a sentence. Okay? So basically, that's the kind of discrimination that we do. Okay? So, but the thing is that with ambiguity is that although, okay, for example, the guys, I hope they will excuse us, we're always using the same example. We have the sentence, I can fish. Okay, so I can fish actually can mean two different things. Okay, so I'm able to fish, okay, or I put fish in tins, okay, or cans. Okay, but each one of those possibilities actually. We say that it's one sequence, but they're actually two sentences. Okay, when we talk about sentences, we're talking more than just linear sequences of words, but structures. Okay, they're two different sentences with two different structures, of course, because actually the words are different. And I'm able to fish. That can is a different word, okay, with a different syntactic category and different syntactic properties that the can and I put things in tins. Okay, so and they have different syntactic requirements that will generate different kind of trees. Okay, so if the system can represent that, then it detects ambiguity. Okay, it detects ambiguity. Of course, it's the system that will detect ambiguity with more complex sentences would be very useful. For example, for editing, especially we always talk about legal text, which has to be extremely precise, no ambiguity. And the thing is that we are so used to ambiguity, and to resolve the ambiguity using cues from our knowledge of the world, that we are not aware, most of the times that what we're saying or writing may be ambiguous, okay? Because we are biased by the interpretation that we intend, okay? But a machine is not going to have that bias. Okay, if the machine knows how to combine, those words and detect that there are more than one way of doing that. Okay, is it making any sense? Okay, okay, yeah. But that's something that we don't think, and the literature that we have reviewed, it seems that probabilistic approaches are not very useful in detecting those types of ambiguities, okay? Because you're not actually training a system with trees. You're just training it with strings, okay? Yeah. So there's no way of discerning that. So we need a system that will actually is able to generate trees from strings, and then do the grammatical discrimination. Okay. But returning to the example of I can fish, even though there are two grammatical structures, the sentence is ambiguous, one can argue that one of those structures is more probable than the other. Okay, so which one do you think that is more probable? I'm able to fish, or I put fish in tins? I'm able to fish. Probably, yeah. That's what. Yeah, our intuition says, and that intuition is not grammatical, because both are grammatical. That intuition is based on probabilities. Okay, so that we can use probabilities for assigning values, not probably value to the different structures. Okay? How do we calculate those probabilities? That's what the neural network approach is useful. Okay, so in part you may say, well, because can as a modal verb appears more frequently in a corpus than can as the verb to put in tense. Okay, so definitely, yeah, we can see that. Okay, on the other hand, and this is the interesting thing, fish in can, when I use can as a modal verb, I have to use fish as a verb. Okay, when I use can as the verb to put in tense, I use fish as a noun. What use of fish do you think is more frequent? Fish as a noun or fish as a verb? But that depends on the corpus, of course. Okay, but in normal use, probably if we're not fishermen, when we talk about fish, we're talking about the not the verb, but the thing. Okay, so somehow you see that the most probable can as a modal verb requires the less probable fish as a verb, and vice versa. Okay, so somehow we have to combine those different probabilities, and we will expect that the I can fish that I'm able to fish still runs first. Okay, as the most probable subject, but the probability is not in terms of grammaticality. Both are grammatical. Is what would be the most probable interpretation? Okay. And of course, that would depend on the corpus that we use to train the system and the frequency of each use of the word. And of course, the corpus will have to be tagged, okay, and identify when fish is a verb, when fish is a noun, and of course, in order to calculate all the probability. Okay? So that part of detecting the different probabilities in the ambiguous structures, that would require deep learning. Okay. Then, in order to just generate the grammatical structures, we're going to use a more symbolic AI approach. Okay, where we have, and then we are basing that on a syntactic theory or a syntactic program called the minimalist program. Okay, what Michael is presenting here is part of that. Okay, so and the classical AI, symbolic AI approach to natural to parsing is what we were saying before. Is computationally inefficient because it was like creating all the possible trees and then trying to eliminate those who are not. But and that's why probably the probabilistic approach is much more efficient than that. Okay, so. But the thing is that was the syntactic theory that we had in the 80s and the 90s. Okay. The thing is that since then there's been a lot of developments in syntactic theory, but they have not had an impact on natural language processing because that route was abandoned in favor of probability, and nobody cared to look at the advancements in syntax. Okay, so what we're trying to do is to incorporate the best of both worlds, let's say, and then that's why this system is hybrid. That's the hybrid part of the system. The parser is symbolic AI. The lexicon will be neural based, exactly probabilistic, and then we combine them. There's precedent. There's actually a system developed by the University of Edinburgh, which actually uses that. It's very heavy though. It consumes a lot of memory, and we want to actually do something that will be more efficient computation. And for that, we're partnering with Dr. Sandy Wei Fong from University of Arizona. He's an expert in computation. He's an expert in computational linguistics. His degree actually is in computer engineering from MIT, but he's a linguist. Okay, so he's been working on this problem. Okay, specifically on the symbolic part. Okay, and but now we actually going to use his expertise and the approaches that we have been developing in order to get this system on. It will be in different phases, okay? At first, we're going to deal only with the generation of syntactic representation, okay? Once we have that, okay, then we may actually use that in order to work on more semantic, domain, okay? So once we have a tree, we have semantic compositional rules that can create a logical expression for the sentence, okay? And we may use that for inference. For example, if we have translated sentences into logical expressions, yeah, we can apply rules of inference. So it will work, it will work for semantics, but syntax has to be done first, and then semantics. Yeah, that's it. Yeah. I don't know if I'm missing something or that. Okay, good. So you.
No, I got the gist.
Okay. And so I should have started with this.
No, I told I was fine with you keeping your flow, and if we get to some point that you can do this, it will be fine. I didn't want to disrupt your flow.
No, that's a but actually it was a very thank you, Naida, for the reminder. More than suggestion, was a reminder. because
Discúlpame, que era que quería que también ellos tuvieran tiempo porque ellos tienen que.
Yeah, claro. So now it kind of makes sense. Okay. So we're good.
Yeah,
Are they gonna present something?
¿Cómo?
Like, are they gonna tell us a little bit about their?
Oh yes, please. Yes, please. Yes, of course.
So let's do this in two very quick parts. I'll tell you what I used to do and what I do.
Okay.
And then Kenny, that has hands closer to the actual fire, can say a little bit about the project where NLP is related. And once again, it is our view of NLP, not necessarily your side in particular views of NLP, which is more fundamental and things. So I'm currently an assistant group leader, and I'm at Lincoln Labs, which is a huge lab for MIT. And we're not necessarily on the academic structure. So I'm going to try to like the super compressed version of everything. There's like 20 slides. Yeah, there's a lot of slides to go over just for this part. So the bottom line is like we're a really big lab at MIT. We're not necessarily connected into the academic structure in terms of degrees. We're just kind of doing research for mainly the Department of Defense. Some few other things, but mainly is what's called an FFRTC, which is a federally funded research and development center. Government usually picks that based on particular interest, and the interest for our FFRTC is the Department of Defense, the main one. So the lab does a lot of radar and a million other things.
Yeah.
They would make me stress the point that they're on the defensive side of things. Right, so they do a lot of missile work, but it's about missile work. Right, like if you're attacking me, I'm trying to figure out what I can do to deter the attack. So that's very critical for them, and it might think that I say that, right? Okay, so but the bottom line is, on my side, I'm an assistant group leader, which is the equivalent of a department to some extent, right? Electrical engineering, and my particular department is called the AI, the Artificial Intelligence Technology and Systems Group, and we used to be mainly focused on speech, extracting information from speech, filtering, kind of we get a lot of speech. How can I go and find the speech that I'm interested in dealing with, things along those lines. And over the last couple of years, we initially moved more to a broader HLP scan rather than just speech, so text and media and other media and stuff like that. Human language technology. And then we morphed again into an AI stance rather than just HLP. And we're applying AI to a lot of different things, mainly media. But there are other things that we would look at, like general elements of AI, a lot of adversarial AI these days, and I'm sure I'm not touching all the pieces that I'm trying to kind of get to. And in particular, my background It used to be on doing speech, and particularly I had a fair amount of expertise on language ID, speaker ID. For neither one of those, I could make a claim, and we could talk about this for hours, but I would make a claim that the way we looked at it is way below the NLP structure side of things. So we're looking at very tiny pieces of the sound, not even a full sound, but it's almost like saying, I'm going to split sounds into even much smaller pieces, and based on that, I'm going to look at a lot of people and either tell you a little bit of what language they speak or identify.
So they identify language or dialect or.
Yeah, that was actually my work for a
Yeah,
10 years.
in
But
intelligence.
I would claim mainly because of data. You know, if we have millions of people that we knew what they were saying, maybe we would bring in a different element of, you know, syntactic and semantic and, you know, keep going up, you know, even conversational styles to say things about either the speaker or what. But we never had enough data to do any of that, particularly not enough label data. So we were always, all the approaches we deal for either one of those had to do with, I'm looking like 10 millisecond piece of the signal, and I'm putting those together, and I'm doing probabilistic approaches and saying, this is the language I'm inferring, or this is the ID or the speaker ID that I'm inferring.
Just phonetic information, formats and things that.
Even to some extent, I would argue that you got some form and structure in there, but that's probably even a little bit bigger than just the form and structure. So even the form and structure might be a little bit higher level than what we're looking at, but the format is about the right level of what we're looking at. So that tells you, I mean, from format to a word, it's a big scale difference, right? Bottom line is, I moved from that, I'm more on a managerial role, I guess, these days. And I did two main projects, one which is still mainly focused on speech. That's a lot of things having to do with still speaker ID, some language ID, some things along those lines. But I also deal with a project that the main person that I'm dealing with, they're called themselves video, image, speech, and text analytics. So the one classical project I got with them is mainly on speech. The newer project I deal with HD, much bigger, it's dealing at everything else, almost everything else except that. We do some video work, we do some text work. Within the text work, that's obviously where at least my project on NLP comes in. And within that, we do things about, we're looking a little bit about concepts of adversarial text, just beginning of that. We're looking at other things about what can the text say, if anything, about the identity of a person. And there's a few other things we're looking at text in general, which once again, where it's a little niche within NLP or Michael. Now, Kenny works on that project, but he also works on other projects. Because he does a lot more NLP that I'm familiar with, I'll let him have his 5 minutes.
Yeah, so I've been at the lab, what, 7.5 years now, so I've been in a few different groups.
Yeah,
I ended up
that's
in the Patriots group. Oh, it's only a few months ago, but it feels a lot longer.
Maybe good or bad.
I'll leave that up to, I'll keep that ambiguous. But yeah, so I work on a few different projects in NLP, and I've been doing that stuff for a while. So I had a different background, technical background, and I ended up in a group that does AI for cybersecurity. So I started working on a project that's doing natural language processing for that. So basically, one thing we were doing is oftentimes when computers have a bunch of different vulnerabilities on the network, there's like a standard way to try to prioritize which ones to patch, but that's been shown to be ineffective. So we created a new approach where we use like natural language processing techniques on the text descriptions associated with the vulnerabilities to do a different way of prioritization and show that the prioritization performed better than the original way. So we kind of like continued, and that's using like classic NLP techniques like term frequency, like counting the words in different documents and like observing frequencies and things like that. So that's an example I'd say of more applied NLP to improve like a problem with different coding. And then on Pedro's project, I think we're looking a little bit more at like, not quite at the academic level of research, but a little closer fundamental research. So like one thing is like he was talking about like taking text from two different texts and determining So there's been a bunch of recent advances, especially in NLP, where these like neural network-based models called transformers outperform pretty much anything that's been done before. So we've been looking at applying those into that problem space, and we've been working with a few different open source data sets and challenges and things like that to really try to build up our models. So we've been doing a lot of work on that. But then the flip side is, Pedro mentioned the adversarial text component. So say you have these models that are performing well, like what do you have to do? Like as an adversary, how would you want to like screw up a model or attack a model to make it perform bad? Especially because AI is now being deployed everywhere more, so now people want to try to attack the AI systems. So we're starting to look at more, again, with the same type of neural network models, but more generative models. So there's these things called transformers. And one of them is called, I don't know if any of you have heard of like GPT-2 or 3. It's like those models that can like generate realistic looking websites or like they can even create their own website now. So we've been looking at using like things like that, sort of in this problem space. There was like research out of UMass Amherst where they took like models like that to try to do what they call style transfer. So, so if like you wrote a text that you wanted to make it look like Pedro wrote it, they developed a way to do that. So we're looking into ways of like extending that and applying it into it. That's kind of like the two things I do in NLP right now. So it's like interesting, where it's like more fundamental research, but then also applying the more basic techniques to new problem patterns.
I should have said something that I should have preempted everything I said with this. So I did grab it from here. To start. I've known NIDA way too long, probably way before a lot of you on this side particularly were born. And the other thing is, within this bigger project that Kenny works on, which is the second piece of why I look at many of these things, is that there is an academic engagement element to it. And what it is trying to promote AI research, trying to increase the amount of people that are getting exposed to AI research. On occasion, collaborating and collaborating on the sense of funding and providing funding for, it could be as much as a narration for a student. It could be something like a project where you might be able to fund a small project at a university capstone, that kind of thing. So, so there's an element that as long as it does help, we generally, or I, because this is completely what I decided to do with that funding. I usually try to comply with the outreach element, but also make it something that's technically within the work that we're performing, that ideally some knowledge could be gathered from there and used for us, either a small piece of a project or something that maybe we're not going to get to because obviously you're not going to get to locate those solutions. So that's also why I'm kind of looking at what work's been done. And I don't obviously have a soft for this for the university. So if I can find some projects or anything like that, it would be great to try to come up with something. Usually we do IAPs, but it's more because we haven't been successful doing both things than anything else. Or if IAP makes sense, we're more than happy to try to come up with a proposal.
We also hire.
Can I mention something? Can you hear me? Yes, I want to mention to the students that Pedro was my first undergraduate research student ever.
Oh, wow.
A long time ago.
When was this? When was this?
So that was something that I'm very proud of. Él es uno de mis pollitos minion, como ustedes le dicen.
So one of the things that you were mentioning was the using NLP, AI techniques to identify author identification. But I imagine you use lexical frequencies And
So that's like often, yeah, so like often with these like challenges, so we follow an organization called PAN, which releases like different problem sets in the area. They call it author forensics. In some sense. So there's always like every year, it looks like always people submit results kind of based on like the classic like lexical things like engrams and all that. But these over the last couple of years, the new neural network models have all started out. But it would probably, probably be the best of the both where you like, I'm sure some of the things that neural networks miss the lexical.
I was actually gonna say that for the most part, the people like us that work on this at Lincoln are either CS or engineers. Very infrequently, it would be anybody with a good linguistic background and or even a good computational linguistic background. So
The rare bird.
I know they are. We've had a few actually, but not many.
Well, in my intro to CS class, actually, we had a project where we had to calculate the trigrammar frequencies of different documents to try to predict what language. And I didn't even know it was like an algebra. But I was like, this is the only project that like this class.
But if it's of interest, I'm more than happy to talk more not to that, but at some other point, about maybe coming up with something, and if it's something that could bring some linguistic knowledge into the kind of things that we do, I would be very interested in kind of discussing that in more along.
Yeah, especially things like parsing arguments and like higher level thoughts.
yeah, this is probably at the level that we are, yeah.
I wanted to ask if you've done any work on motifs.
On what?
Motifs. So like automatic motif indexing. So for example, really it's meaning like understanding recurring themes and ideas in sentences or paragraphs or all these types of things.
So my understanding would be inaccurate. That sounds to me like a little bit more, I mean, we a lot of the things we're gonna do are very application driven, right? So you would need to put it into a very particular context and this is why we do that. Now that said, there's other things that we might do a somewhat, I'll give you an example of something which is not quite that but there has been some work we've done over the years in understanding narratives and understanding how narratives are moving opinion and all of that. And one thing that's really emerging, and I know we're like we are and not necessarily, not getting political, and not necessarily on the US mainly right now, right? But this it hasn't been shown to happen here in any way of that kind of effect. But you get all this issue with misinformation and election moving and all of that. And once again, you can say whatever you want, but people don't go out here saying, oh, this guy won because we had Facebook and that you have a lot of in the US. So one thing we're dealing also, and we're spending a fair amount of money, and it's of a lot of interest for our group, is this concept of, depends how we want to define it, either influence operations or information operations, depending when you talk to, they have slightly. Yeah, I think yeah. But the bottom line is, influence operations is almost at least semantics or above, but you need to build kind of all the framework to be able to say, can I detect it? Can I put it together? Can I say, do anything at the semantic level? And maybe I'll be able to say something that there's something at the influence operations happening that I should be doing. So a lot of work is emerging on that area. Lincoln does, I'm assuming this is pretty big out for many of the labs, but Lincoln consistently identifies areas of interest for the government and decides to spend its own money. It's never its own money, it's always the government's money, but it's money we have control of, into areas that we believe are areas that are either overlooked or emerging areas, and we want to put our own money to try to get it going and then get the government sponsor it, right? So that's a perfect example of an area that we're looking into. I'm not doing a whole lot of work at the IO at the high level, but the projects I'm working on do a lot of work at the primitives of what would eventually build the IO infrastructure. Once again, I know I didn't answer precisely your question,
But like an example to that might be like if there's like a Twitter bot out there and the Twitter bot is designed to be interested in like baseball, but then you notice that it's not tweeting about the World Series, that might be weird. That might be something you try to detect, like looking at the topics it's talking about over time.
Yeah, there's that, but the thing that I was really, or an example of what I meant is, for example, incels. So I can't remember the name of the mass shooter in Canada. Yeah, is an incel. Probably not. He used a lot of incel motifs in his YouTube videos. So detecting those motifs preemptively. And, you know,
I'm not familiar with specifically that being worked on, but I would guess it falls under the general window of IO, which then falls into the kind of things that we would consider working on as primitives or blocks to build on toward getting complete.
Yeah, I wouldn't say we do any work in like that specifically today, but those ideas of like detecting like fingerprints or patterns and stuff like that are very absolutely.
I know this is not exactly, what we were talking about, but, there's a lot of, well, I heard a lot of critique towards the system or the algorithm that, for example, Facebook and YouTube use to detect misinformation. Because it probably just frequency based, and if they, if they detect some combinations of word, combination of words that, more than would be normal, okay? Then, we identify that video, whatever, as misinformation. But the thing is that it's actually tagging as misinformation those videos that actually denounce the misinformation.
Yes.
Because there's no way, just by frequency, to identify, to separate one from the other. Yeah. So I guess my guess would be that you need something at a higher order in order to distinguish talking about something or claiming that. Right. Okay, because they're different, they're discursively different, but that's at the level of discourse. Yeah, so that's
well, and I think once again, I kind of track IO from a distance. I'm not particularly at that high level of doing the IO inference, all that. That's kind of a little bit outside of what I do. Kind of do things about those core pieces and do work and support, I guess, I would say. Those core pieces. But my guess is yes, one problem that people keep criticizing IO, the concept of IO is, for you to say something about a misinformation campaign, especially if you're coming from the current state of the affairs for AI, you want a lot of examples, a lot of cases, and you don't have that, right? Like you have maybe one case of misinformation campaign. It's just one example in the big context. There's a lot of other things happening to make it a misinformation campaign. But in my mind, as things are today, AI is a solution for the core pieces and somewhat intermediate pieces, but you need something else to bring in to put all of those together and be able to say something. Because it's not going to be statistically, because there's no statistics to be had because you have very few examples of the full process.
Yeah, what you want seems more that it looks more like what humans do. So we understand every sentence that we hear, and we hear the sentence only once.
Yes.
It's the first time. So we actually we use statistic knowledge in some parts probably of language development, like for example in acquiring our phonological system. Because babies at 6 months they produce any kind, and they distinguish any kind of sound from the word. Okay, and after 6 months, they start to lose the sensibility to certain sounds. Sure, that has to be statistically, you know, that.
Yeah.
But and that's why it's, people can have a perfect syntax in the language, but you know that they're not native speakers, it's not because the syntax is so hard. It's it seems that that is a quite very good.
There's
Yeah, so, no, yeah.
No, I was gonna say that there's another project that we really haven't, I mean, not another project, but there's a task that comes from one of our sponsors. The sponsor of that big project. He does come in from a linguistics side. And his view of the world or what is long-term vision of things, not necessarily in the IO space, but in general is that what he would, the kind of things he would like to build is something along the lines where you're able to draw inferences from a lot of knowledge that gets gathered together, but that inference is almost comes in from a knowledge of the world rather from an example you've seen necessarily, right? Like you could say, I mean, to put a very simple example, if I show a human a video of a guy that jumps on a trampoline and I show you all the way till he's on the air, the human obviously knows he's going to go into the pool. The machine may see the guy and the only thing the machine would say is there's a guy in the air, and that's it. The machine will not necessarily draw the next step, logical or what, you know, knowledge-based world. That, yeah, this is what's going to happen. And once again, that's not necessarily the best example, but the concept he wants to come up with is, if I start populating all the information and I have additional understanding of the world that I somehow incorporate, I'm not quite sure how, but somehow you incorporate, you will be able to start drawing inferences and basically at the end, that's kind of like the lofty long-term vision of things. But on a daily basis is, if I'm a human and I'm analyzing a little bit of this part and a little bit of that part, usually you analyze like, oh, this happened here on a site, right? And I'm able to say, you know, the guy was on a horse. This other silo gets me additional piece of information. This other silo, and now the best we can hope for is a little bit of drawing those together. That's the best we can hope for. I mean, meaning from the machine side, right? From the human side, yeah, you can come up with. So he wants to say, if I'm able to put all this information together, can I start, instead of just taking an analytic and somehow drawing an inference from the analytic, can I put the analytics together and can I even put in additional information to start developing hypotheses of what all these things that I'm observing could mean? And rather than doing a single document view of things, and I can say something about the document, and then to do the same thing, can I join a lot of documents, put them together, conceivably on a knowledge base, and then start drawing hypotheses of these are the most likely things that I'm potentially observing. Now, at least on the engineering side, we're far and away from doing any of that. Now, the question is, if you do that, you keep improving analytics, you keep improving, can you start drawing that semantic and knowledge piece of things down the road? But that is really the long, lofty goal of this project.
I'd like to add something. If you remember our conversations, you know, this is that line of thinking is actually what I'm very interested in doing for research in graduate school. I'm really interested in that interaction mainly between semantics and the logical component, but seeing at the very least with possible things to say, right? Like, you know, you can say something to someone, they could come up with their own logical hypotheses or whatever, and they can respond to you back in a natural way. That comes up with like a relevant question or something based on a knowledge base, based on variables that they're missing, based on previous experiences, based on an ever-changing, like a dynamic context versus an everlasting context. And trying to see that, say that we start with a sentence in syntax, we compose a tree, turn it into, or use the semantic to turn it into logical form, use those logical forms into a component to make inferences, say that you're going out on a rainy day, the computer can infer that, oh, you need something to cover yourself up, but it doesn't know if you have something to cover yourself up. It recognizes that there's a variable, turns them into logical form, which then can use semantic processes to create a syntactic structure and then ask you, hey, do you have your raincoat? Right? And stuff like that. That's actually exactly what I'm
That's
interested
something
in.
you're interested in. We should talk down the road.
Yeah, no,
Because
definitely.
We do wanna keep expanding on that area. And we don't necessarily get, we get a lot of really good people that want to do semantic, the analytics. But we don't get enough people, again, you said we don't get any, that maybe one, that are really interested in that semantic and above piece.
Yeah, because it's definitely the toughest part. I feel like, especially when you have the knowledge base involved and you need to get context and previous information as well as like discourse domain and whatnot, it gets extremely rough. And being able to know what to infer in the first place is one of the toughest problems in the whole thing. So
That's where we are moving long term.
Yeah.
We're, as they say at work, we're not necessarily on the right phase, which what really means is, this is a completely unclassified discussion we're having, and that's all we can do. But if we were talking in more detail on a classified space, we can really go into the very particular and specifics about what is it that we're talking about. Rather than just throwing examples in the air. But the bottom line is, if that's something you're into, we should talk.
Definitely. It's something that, I mean, you've noticed this whole semester, it's something I've been super interested in getting to know more about. So
Yeah, well, you want to start by the IAP, my role at the IAP is not, Naida's not listening, but my role is at the IAP.
She's right here.
And they actually, yeah, I think they're actually, definitely two approaches to.
Absolutely. So I mean, even the concept of a hybrid approach sounds really good.
The bottom up thing where we start with primitives. Yeah, definitely, you need to be, we need that.
Yeah.
But that actually is going somewhere.
Yeah.
So actually that approach top down, it gives you the goal, okay? And somehow they can be developed probably simultaneously. You get to the middle.
Yeah, they gotta get at the middle, but they gotta be somewhere.
And then you get into it.
Exactly. Yeah.
But I think it has to be worked from both directions.
Yeah, I feel like it's the only efficient way it's gonna work.
What I wanted to say about my role at IAP, especially when I bring other people. My role at IAP is not necessarily to see every single presentation, but to have discussions about things we can collaborate on, talk about projects. So I'm here to today, yet tomorrow, like 10 to 3, wherever, Naida, donde es la presentación de IAP. Celi.
La presentación es en el anfiteatro de CELI, pero las demostraciones. Las demostraciones van a ser a las 3:45 aquí en este laboratorio, parte de las demostraciones. Las otras van a ser en el laboratorio de control. Van a ser en CELIS 116, que es el anfiteatro de CELI.
That's where I'll be tomorrow.
¿A qué hora?
Esas son a las de 10 de la mañana hasta las 3:45. Y a las 3:45 y las.
Si alguien quiere hablar conmigo, vaya, yo saco la presentación.
Y a las 3, Pedro, a las 3:45 son los demos, y los demos son en 3 laboratorios: el laboratorio de IoT, el laboratorio de controles y el laboratorio de robótica. ¿Ok?
Pero lamentablemente a las 3:45 Pedro va a pasar.
Ok, no hay problema. Pero un detallito, Pedro, que cuando NSF vio nuestra propuesta no encontraba evaluadores, porque la parte teórica del trabajo de Hilton y de este grupo en particular, pues es bastante difícil encontrar evaluadores, porque no mucha gente trabaja en esto.
Por eso, pero de nuevo, obviamente no estamos hablando de resolver el lofty y súper amplio problema, estamos hablando de que dentro de las cosas que ustedes están haciendo y los intereses que nosotros tenemos, podría haber una otra pequeña colaboración que puede ir desde hacer unos de otros proyectitos de IAP hasta hacer unas cositas un poquito más avanzadas, o empezar con unos proyectos de IAP y tratar de mover eso a algo más avanzado en el futuro. Todas esas cosas están sobre la mesa, un espacio de posibilidades. Exactamente.
encontrarte en el medio. Mira, el lapso, ¿verdad? Sí,
Yeah.
Muchas, thank you very much. I hope you were having for you today.
No, it's interesting more than linguistics.
Yes.
Jóvenes, yo me tengo, gracias un millón, gracias.
Sí,
Y me
no,
tengo que
gracias.
ir, que tengo que cocinar, yo soy.
Bye, está bien.
Nos vemos, cuídense.
Okay. So, hopefully, you know, see tomorrow.
Yes, absolutely.
¿Verdad?
616, todo el día mañana.
Okay.
I'm gonna have to go over there then. I'm gonna have to go over there then. Check it out. I'm gonna have to go over there then. I need to check it out.
Sí, nos vemos, Naida.
Si yo me salgo y para la casa,
You know, there's like, this is the last slide, so I want to go over this before, like, for whoever stays, to just kind of finish this up, because this, the next slide is like the title card for the next section, so like, might as well finish this section really quick. We never got to movement, but we're gonna get there.
We'll figure out things.
Si hay algún hyperlink que quiere estar, ¿cuánto tiempo va a tener? 5 minutos.
No, this is gonna take like a minute, right? Like, it literally, we're just missing the example. We're just missing the example because, yeah, no, literally, all you're missing out on is just to show how bad of a situation this is without movement. The next section, the next time we meet up and do this presentation, we're gonna actually start movement, right? But this is just to show you that, like, you know, with a sentence like "you can fly," based solely on the theta grids and on the X-bar rules and all the filters that we've applied so far, this sentence is grammatical and perfectly fine, and we don't have to touch it. But
Como I can fish.
exactly, but if we want to turn it to a question, like we mentioned before, we would usually turn this to "can you fly," right? So that "can" is no longer right next to its complement. It's actually farther above in the sentence, right? So
Like what was it called last time that you showed? There's an like it has like the brackets, square brackets. You don't
Trace,
the trace, yeah. So the trace stays there.
yeah, what we haven't gotten to trace yet, but yes, if when it moves, there will be a trace. But if with our current rules, we don't really have a way to put "can" over there, right?
That's a bad tree.
We can't do that. This is not a tree, right? And this plus Q, all it's saying is we're trying to turn this into a question, right? But note that with our current rules, we can't make this, right? It's just impossible. And that is the case with almost, if not every single question, right? So how do we do this? Well, the next time we meet up, we are going to get into our powerful solution called movement.
So that'll be for next time. Pero nada, la idea es que sé que uno de va a estar poniendo sintaxis el semestre que viene, así que vamos a ver cómo. But the thing is that it's good to know, ¿verdad? Es bueno saber por qué estamos implementando las cosas que estamos implementando. O sea, no simplemente, ¿verdad? O sea, hay una necesidad de orden pragmático y teórico, ¿verdad? Y eso es más bien el propósito, ¿verdad? De hacer esta presentación. Pero nada,
Había dicho un comentario que me quedé pensando y quería challenge, no sé si es decirlo, ¿no? Dos cosas, uno que todos los lenguajes son lineales en el input.
el output y el input también.
Pues,
Sí,
y